Good day, folks. This is the solution for your test one questions. So this is the very first question, uh, on the long answer questions. So a bullet of 8.75 gram bullet travels with 351 meters per second before striking the stationary 2.5 kg ballistic pendulum. How high will the pendulum swing? So if I look into this question, I will write the equation m1v1 plus m2v2, which is a conservation of momentum equation, m1v1 plus m2v2. This is the equation. This is final. Here it is initial. I'm going to put in the values. This all is before collision. So there's a pendulum like this, and there's a bullet. Well, let me redraw it. So there's a bullet, and then there is a pendulum like this. This bullet, after collision, hits in this pendulum, and this pendulum moves somewhere in the upward direction once the bullet hits into it, and it gains certain amount of height. And we wanted to find out how high the pendulum swings. So thus I wrote this equation, and now I'm going to put in the value. So this is the mass given us in grams, so I have to convert it into kgs. 875 multiplied by 351 plus, well, let me rewrite it, 351, and then plus 2.5 times 0, because initially the pendulum is at rest, equal to 2.5. I can add up the masses. First of all, m1 plus m2, and multiply by V2 final, because the bullet gets embedded into the pendulum. Now this mass will become equal to 2.50875 V2 final. And down here, this value, once you're gonna calculate, you're gonna get some value from here, and divide both sides by 2.5075. 2.5075, you're going to get V2 final equal to 1.22. 1.22. That's what you're going to get. And then we're going to find out the height. So G value, G is equal to 9.81 meters per second. Height is what we are looking for. So we're going to write down kinetic energy is equal to potential energy, which is mgh is equal to half mv square. Mass are same. So we just gonna compare the velocities. Half times 1.22 square equal to 9.81 times h, and the h value will come out to be 0.0758. So you can call it as 7.6 centimeters also. Now the part B. This is not mandatory. Before I move to the next question, you can just leave it in meters also. I haven't deducted anyone's marks if they haven't converted into centimeter. All right, so in the second question, this is more about a one-dimensional question on the momentum. So mass of the football halfback carrying a ball with combined mass of 95 kg leaves towards the goal line with this much velocity. And in the air, the goal line, he collides with another 115 kg linebacker traveling at this much. If the player moves together after the impact, will the ball cross the goal line? So we will write the equation m1v1 plus m2v2 equal to m1v1 plus m2v2. And this is initial, this is initial, this is final, this is final. So this is 9.5 times 4.8 plus 115 multiplied by 4.1. Well, this is person is moving at south, so I'll mark this one as negative, plus m1 plus m2 times v final. And this is negative 456 plus 451.5, which is equal to m1 plus m2 times v2 v final. Now if I see in this, I don't need to find any of these things, final velocity. So it's just basically it's asking if the players move together after the impact, will the ball cross the initial goal line? So I can clearly see from here that this value is bigger. So this negative value is bigger than the, well, this is 471. So this is smaller, my apologies. So this is smaller than this value. So thus, if this person is moving in the south direction and the other person is moving in the north direction, and the person who's moving in the north direction has more momentum. So obviously this person will be able to push the person backwards, the person who's moving towards the south. He's going to get moved towards the north direction. So the answer to the question will be, will it be able to cross the line? No, it won't be able to. All right, let's look into the next question. Next question is the one where a lot of students made the mistake. So two identical ball spheres given to us are in a fixed position 2 meters apart. Calculate the electrostatic force acting on the two charges. First part is really easy. So we're going to use force equal to kq1 q2 divided by r square. 9.00 times 10 to the power of 9 multiplied by 5 times 10 to the negative 5 multiplied by 6 times 10 to the negative 5 divided by r square. 2.00 square, which is going to give me 6.74 as an answer, Newton. For part B, if the two spheres are touched together and return to their original position, calculate the new electrostatic force. So both are positive charges. So this is 5 times 10 to the negative 5, and this is 6 times 10 to the negative 5. Both are positive. So what's going to happen in this case? They're both going to come together and they're going to equally distribute themselves. The question on the videos which I did, in that one was negative, another one was positive. So thus you subtracted them. In this case, you will add them because both are like charges. So the total amount of charge on these two will be 11 times 10 raised to the power negative 5. These two will add up and they will equally divide themselves on both the spheres. So this will be 5.5 times 10 to the negative 5. This will also be 5.5. Oops, 5.5 times 10 to the negative 5. Okay. And then now I'm going to simplify the value. Force value is 9 times 10 raised to the power 9 multiplied by 5.5 times 10 to the power of negative 5. I have 5.5 times 10 to the negative 5 divided by 2 square, which is 6.8 newtons. That's how we're going to get the answer for this one. All right, let's look into the last question. A ball with the mass of this much, 2.7 times 10 to the negative 4 kg, positive charge of this much, initially rest at location A, electric field with the in an electric field of the large charge at this location. The charged pitch ball has 3 times 10 to the negative 7 joules of electric potential energy. When released, the ball accelerates towards the other charge. At position B, it has this much joules of electric potential energy. Find the speed of the pitch ball when it reaches to the position B. So this is a big charge and this is a small charge. This has a mass of 2.7 times 10 raised to the power negative 4 kg, and it has a positive charge of 1.4 times 10 to the negative 8 coulombs. It is at rest at location A, and this is also a positive charge, and it reaches its charge at this location. The charged pitch ball has this much joules of electric potential energy. So 3.00 times 10 raised to the power negative 7 joules of potential energy it has. But then it is released towards the negative charge. Once it reaches to the position B, it has 1.56 times 10 to the negative 8 joules of energy, potential energy remaining. We wanted to find the speed at this particular point. So I'm going to use the conservation of energy equation. EPE plus EKE equal to EPE plus EKE. This is the equation I'm going to use. So whatever the total electric potential energy is here, total energy is here, same amount of energy will be here. Total energy at A and B will remain same, but there will be a change in the potential and kinetic energy. So initial kinetic energy is 0. Everything is in the potential energy because it says the charge is at rest. So 3.00 times 10 raised to power negative 7 plus 0. And show you here. Also charge is at rest equal to the second location. This is the potential energy 1.56 times 10 to the negative 8 plus EKE, kinetic energy. Kinetic energy is what we are looking for, half mv square, because we're trying to find the direct speed from here. So this is going to go on the other side, 3.00 times 10 to the negative 7 minus 1.56 times 10 to the negative 8 equal to half mv square. And then I'm going to plug in the values of mass and figure out the velocity. 10 to the negative 4 here, 10 to the negative 4, and v square. This is going to come across as 2.844 times 10 to the negative 7. Now the next number will be, you can once you're going to do the calculation, you can do the calculation on your own. V square will come out to be 2.103 times 10 raised to the power negative 3, and V value will be 0.0458 meters per second. So hopefully you know how to solve these questions. And if I'm not been able to mark all the tests, so you can always go back and look into your mistakes, and that's the whole idea of posting this video. Okay, I'll see you with another video. Till then, goodbye.